Good day, I am Mikel Goldones, and the time has finally come for me to do my course project. So, over here is the address table for the list of IP addresses which I will um, program into my devices that I have used in creating my network topology in Cisco Packet Tracer, which is right over here. And I also have listed a list of commands which I will use for programming our network. So over here is a list of commands that were designed or that I tallied based on the tasks given in the course project. Number one is performing the initial configuration. Number two is configuring the switches with VLANs and trunking. Number three is for inter-VLAN routing. Number four is the various routing protocols. And number five is testing and verifying connectivity. So, without further ado, let's get into it. Now, while I continue the configuration of my routers, I will go back to router 1 and I will eventually be able to do task 3, which is inter-VLAN routing. But let's continue. Now that I am done with task 1, it is time for us to move on to task 2, which is VLAN and trunking. So let us continue. Alright, so now that I have finished tasks 1 to 3, it is now time for me to move on to task 4, which is to enable the routing protocols in each of the 4 routers in our network. So let's do just that. So after doing tasks 1 to 4, I noticed a few insufficiencies in my configurations, particularly with the routing process. So let us now check to see if those configurations have been corrected with the show IP route command. And as you can see over here, there are a couple static routes that I programmed since upon my checking off camera, PCs from the other routers could not reach the PCs from router 1, so I had to configure their routes, their IP routes, into the static routing protocol of our show IP route command. And that's also the same with R2. In order to be able to um, ping the PCs or access the PCs that are connected to router 1, I had a lot of static routes to configure into our router, and same with router 3. So you can see all of these routes are marked by the letter S. These are all static routes, and same with our router 4. And another way of checking if our routes are configured or our hosts are reachable is to do the show ARP command. And as we can see over here, this is the gateway to our PC9, which is connected to R4. And I did that show ARP command on router 4. So that means that our connection between router 4 and PC9 through switch 6 is good. And let me do this also for router 3. As we can see, the gateway towards our PC8, which is connected to switch 5, which connects it to router 3, is good. So that is good as well. So let us do this now for router 2. And same, we can see the gateway for our PC7, which is connected to switch 5, that connects it to router 2. And finally, for our router 1, let us do the show ARP command. And it shows the gateway to our switch 1 over here, which connects switch 2 and switch 3 to our to the various PCs, which are 3 per switch over here. So now let us begin the verification process by pinging the respective IP addresses of our hosts and our networking devices. So first, let us ping our router 2. IP address over here to test if router 1 and router 2 have good connectivity. And as we can see, it is a success. So now let us do the same for the IP address of router 3. And would you know that it is also a success? And finally, let us do it again for the IP address of router 10. And it is also a success, but unfortunately I was logged out, so it cut out while I was pinging that. But let us enter our password and continue the pinging process or the verification process in order to see what it has to say. And yes, it is indeed a success. So now that we are done pinging our other routers from our router 1, let us try to see if the end devices in router 1 can ping the end devices in the other networks and vice versa. So let me hop on to PC1, to the command prompt of PC1 over here, and let us ping our other end devices first on this network, or the end devices that are connected to our router 1. So let us ping 192.168.20.10, and it is taking some time, but I believe it will be a success since we have configured this properly. And even though one packet was dropped, we can see that the other three were indeed successful, only indicating a 25% loss. So let us now ping our PC3's IP address to see if we will get the relatively same results. And as we can see over here, our first request timed out, but our next three requests are successful. Now let us ping the IP address of PC4 over here. And as we can see, our first request timed out once again, but the rest are successful. And I believe that doing so, we will still be able to reach the other PCs since we have confirmed that PC1 can reach the hosts in the other devices. So now let us go on to ping the end devices on the other networks through PC1, starting with the IP address of our PC7. So it's 72.16.50.4. We're gonna ping that right now. And as we can see, we got a reply, although we still have a 25% loss. But overall, it indicates a success. So now let us ping PC number 8, the PC that is connected to our third router. So 172.16.16.4. And as we can see, it is a relative success as well. So finally, let us now ping our furthermost PC, which is PC9, which is connected to router 4. And we also got a 75% success. So now we know that our PCs in our first network, or the network that is assigned to router 1, can ping their interconnected hosts. But do we know that the hosts from other networks can ping the end devices that are connected to our router 1? Well, let us find out. First, let us ping our router 1 or the PC1 IP address from the command prompt of PC number 7. So here, and immediately we have our reply, so that indicates a success. Now let us try pinging PC2, and immediately we have a success as well. So why do we not want to try PC4? Being 192.168.30.20, and we also have an immediate success. So let us try doing that at the same time for PC number 8 to see if this device can also access the host devices on the first network, or the network connected to router 1. So let us do just that. and it is a relative success of 75%. Now let us try picking PC6 from PC8, and it is also a relative success. So why don't we try picking the furthermost PC or PC1 from PC8? And it is an immediate success and a complete success since we got a 100% received rate. And now let us try to do this for PC9 to see if our network topology is indeed well configured. And let us head over to the command prompt and ping PC1's IP address. And it is an immediate success. We received the reply immediately and no packet was dropped. So let us try pinging the IP address of our PC4. It is also an immediate success. No packet was dropped. Let us try the IP address of PC number 3. It is also an immediate success, and I believe this would be the same result for all the other PCs that we have pinged or that are connected to the network that is assigned to router 1, deeming this network topology that I have configured for my course project a success, a very satisfying success, since this actually took me quite some time to make. But thank you for watching this course project. I hope that you were satisfied with my output. And to whoever else is watching that is obviously not a professor of mine or not checking my course project, I hope you can find ways in order to make the routing of this network topology more efficient in order to be able to reach the hosts faster and not have any packets drop. And so what else can I say? Thank you for watching and have a blessed day.